Alright, so on Friday, we're going to be looking at just solving for x. So not just simplifying anymore, like we had done the past couple days using double angle, but we're going to go and solve equations after we do double angle substitutions. So this is kind of tying back to the same kind we did with angle addition and the same kind we did at the end of the last unit where we were solving for x on a given interval. So here, all of these, we're going to stick to the first rotation, 0 to 360. We're going to solve for x, meaning we could have two answers for, or sometimes even more. So this first one I wanted to do with you. We're going to do two here, and then we'll do two more in class, and that way we should hopefully clear up any questions or clarifications, and then we'll move on from solving to our last topic. So this first one we have sine 2x plus cosine x equals 0. So when I look at this, I have two different functions. I don't have anything squared, so I can't use a Pythagorean identity, but I do have a double angle. So if I take and look at my double angle for sine, I can use the sine of 2 theta equals 2 sine theta cosine theta. So this is our double angle rule. We can use that and substitute in for our sine 2x. So I can rewrite this as 2 times sine x cosine x. So now I've at least gotten rid of the double angle part. So we're already equal to 0, which means our brain should be thinking, how can we maybe factor this so that we can use our zero product property? So when I look at the two terms I have, they both contain a cosine. So if I factor out a cosine x, we're left with 2 sine x plus 1 equals 0. So now we're at a point where we can separate our factors and find x. So take each factor and set it equal to 0. So we ask ourselves the question, what angle, when we take the cosine of it, gives us 0? So going to our unit circle, where would we have 0 on our unit circle on the outside? We would have it when we're at 90 degrees and at 270 degrees. So there's two of our answers. Over here we have to do a little solving for sine x minus the 1 divided by 2. So we ask ourselves the same question. What angles, when we go to our unit circle, when we take the sine of it, gives us -1/2. So when we go back to our unit circle, it would be the 30-degree reference angle, which would be 210 for quadrant 3 and 330 for quadrant 4. So together, all four of these would be our solution. So hopefully you guys have become more comfortable with the solving. We've now done it for quite a while. We're just now solving using these new properties to help us in our solving process. Okay, like I said, I wanted to do one more tonight with you, and then we'll do two more in class to make sure that we've clarified any questions or concerns. Okay, the second one, 1 minus 3 cosine x minus cosine 2x equals 0. So again, when I look at this, first thing I notice is that I again have a double angle. Because we're learning about double angles right now, we're going to see those a lot. So the only issue I see is that for cosine 2 theta, we had 3 options to pick from. So our first one was cosine squared minus sine squared. Our second option was 1 minus 2 sine squared. And our third option was 2 cosine squared minus 1. So we have to pick the one we want to use. Now, there is a way to tell which one you might want to use, but it all comes with practice. So we have to, in order to be able to tell, we have to think ahead. So we know we're going to have to try to either factor this or combine like terms. Otherwise, we're going to get stuck in our solving. So when I look at what my problem has, I have another cosine in my problem. Okay, so if I was going to factor, I need it to stay all cosines, because if I throw a sine in there, it's going to throw off my ability to factor. So when I come over here, there's only one option that has a cosine only in it. And so that's going to be the one I use. So how you can tell which one is you have to kind of think ahead with, if you plug this one in, will you get stuck, or do you have some things you could do? And sometimes you might pick one and start and realize 3 steps later that was the wrong one. Just go back and try a different one. Because there are times where certain ones will lead you to a dead end, and another form will get you where you want to go. So for this one, because I have other cosines in my function, I want to try to keep it all cosine. So I'm going to use this third one so I can keep everything as a cosine in my problem. So I'm going to go ahead and substitute, and I'm going to make sure I put my parentheses because I'm going to have to distribute that negative. Oh, I need to use x, not theta. So when I distribute the negative, I'll end up with 1 minus 3 cosine x minus 2 cosine squared x plus 1. I have some like terms I can combine, 1 plus 1. So let's see, I'm also going to reorder this so that my cosine squared is at the front, my cosine is in the middle, and then my plus 2 is at the end. So by rewriting it, I've set it up to do a double bubble. So I'm going to set up my parentheses. If you like to divide the negative so that you have a leading coefficient, that's fine. Just remember, when you divide by the negative, all of your signs will change. So we have negative 2 cosine x and cosine x. And then I need the 3 to be negative. So that means when I put the 2 here, I want the 2 to go with the negative 2, so I get negative 4. And then I'm going to put the 1 over here. So negative 4 cosine x plus 1 cosine x will give me negative 3 cosine x. So then once we have it factored, we can set each factor equal to 0. And solve. So here, when we solve for cosine x, we're going to get cosine x equals to 1/2. So we ask ourselves what angle, when we plug it into the cosine, gives us 1/2, and that would be 60 and 300 degrees. Also over here, we'll have cosine x equals negative 2. So what angle, when we take the cosine of it, gives us negative 2? The answer here is nothing, because all of our cosine of our angles has to fall between negative 1 and 1, and this falls outside the range. So therefore, our only answers are going to be this 60 and 300. Okay, so like I said, we're going to do a couple more. We're going to, and they're going to be sines and cosines still, to make sure we're okay with how to solve these. We're going to do definitely another cosine one to show you how to, again, maybe choose which of the 3 forms you're going to use, because that's sometimes where we can get hung up when we are substituting in for a cosine double angle. But go ahead and make notes of any questions. Like I said, we have 2 more to go over in class, and then we'll move on to double angle proofs.